And the final question, 17, I don't know who put 17 questions in an exercise, has got these intersecting sectors. So really the shape looks like this. We've got that bit there to find, and I'll do that bit in a minute. But just first of all, to find out this part here, and that part there is just the area of the first sector, take away the area of the triangle. So we've got a half times r squared times by theta, take away a half times by r squared times by the sine of theta. So that's the first part there. And that I'm getting 1.271 for that part there. Now I said that was 1.271, but just tapping it into the calculator and checking, it's not. It's 3.349. This bit comes in later. Don't bother. Now we're going to do the same on this side here, but we don't know this angle yet, do we? So if we're going to find out that angle, we know that distance there is 12. And what I'm going to do is I'm going to think about what this distance there would be, first of all. So I'm going to say that the sine of half of that would be 0.6 equals opposite over hypotenuse. And so my opposite side is 5 times the sine of 0.6. That means if that's the 5 times, now I'm going to look into this triangle here, and I'm going to put this angle here as theta. And I'd say that the sine of theta is equal to the opposite, which is what we just had, divided by the hypotenuse. And so working that out, I've got 0.23749, but of course the whole angle so that we want is double that. So times that by 2 gives me 0.475 as that angle. Right, so now just doing the same thing there, I'm going to do the big sector is a half times by 12 squared times by the angle I just did. Take away the triangle, which is a half times by 12 squared times by the sine of the angle we just did. Oh, and that's the one that gives the 1.271. Oh, that's annoying, isn't it? I don't want to go back and redo that again. So just typing that in, I've got 3.349 for that bit there. Add these two together to finish off with, gives me 4.62 centimetre squares for that part there.